Hey guys, what's up? I see Arna, Unmana, and Vatsala. How are you guys? Vatsala, is there any chance you can log out and try logging in again? And when you're connecting to the microphone, instead of clicking on listen only, can you click on the microphone option where you run the echo test? Because I see you're the only one on listen only mode. That means you cannot speak. All you can do is listen and type. So I cannot talk to you and interact with you. Are you there, Vatsala? Okay, so Unman and Arna, are you aware of what we're going to do? Do you remember where I left off last time?
Yes, the triangle and its properties.
Yeah, so you know why I came back? Because I had started the session, I had started the topic, so I did not want someone else to take over in between, so I thought I'll finish it with you guys. So today is session 3 of triangles and its properties. It's the final session before we close it. And one second, Vinay sir, are we waiting for someone else? I think there are a couple of more students who are yet to join. All right, we'll start in a couple of minutes. Anyway, so today's class, I don't know, guys. I want you guys to fall in love with today's class. It's going to be really, really interesting. I am going to make it interesting. Don't worry about it. Today's class is very interesting because there are very few numbers that are going to be involved. Other than the problems, I don't think there are going to be numbers anywhere when we are learning the concepts. There'll be a few of them here and there, but not dominated by numbers. First of all, we are in geometry. Geometry is more about imagination, right? And today we are going to learn things differently, as it is in every class. So are you guys ready? Unmana, Arna, and Vatsala, if you cannot speak, if I can't hear you, type in so that I know that you're there. I know that you're listening. I don't want it to be a one-way street. There's no point of you being in the class if that's the case. Yeah. So Arna, Unmana, you guys ready?
Yes, sir.
Mr. Vinay, can we get started? Are we waiting for someone else? Priscilla is here. Hey Priscilla, what's up? How are you doing? Did Priscilla join and fall asleep?
No, sir.
How are you, Priscilla?
Fine, sir.
Why didn't you attend the Sunday session, our personal mentoring? Where were you? All right, thank you, Vinay. Where were you, Priscilla? Why weren't you a part of it? Are you there?
Talking about the last Sunday.
Yes. The one on Sunday, Arna, where I spoke to you. I spoke to Unmana also. I did not talk to Priscilla. She wasn't there. Nor was Vatsala.
There. Sir, she also answered, I remember.
No, I'm not talking about the mental ability session, Arna. I'm talking about the personal mentoring session. Yeah. You remember the one-on-one?
So which session, sir?
So the personal mentoring, Mohan sir and I had a personal mentoring with Arna. We had it with Unmana also. You weren't there, Priscilla. I think you missed it or you were probably busy that day. It was a Saturday, last Saturday.
Okay, sir.
Yeah. So let's have you scheduled for this week. Make sure you do it. So Priscilla, today's triangle is the final session because I had left off and I wanted to close the topic for myself and I wanted to take it further and close it for you guys also. So it's session 3. It's the final session. It's a very interesting session. Trust me, we're going to look at ways in the simplest of forms, understand the most difficult concepts in the simplest of ways. Number 1. Number 2, we are going to have minimal numbers. It's going to be more of a logical class, most of it based on observation, etc. Numbers are going to come in obviously when we're going to solve problems, but while we're learning, we'll try to make sure that there are minimum numbers involved. So are you guys ready? Can we get started?
Yes.
All right.
Yes, sir.
You can see what I've written on screen.
They're writing
Yes,
good
sir.
evening.
Yeah, sure. I was just testing. Okay. Now I want to see how much of the topic you guys remember. Who can tell me why or what was the most fundamental proof of the three interior angles adding up to 180 degrees?
Okay, Radha.
Yeah, Priscilla, go ahead.
Sir, you had told that when you open up a triangle, it forms a straight angle, and a straight angle is equal to 180 degrees.
Beautiful, beautiful. Arna, Anmana, and Vatsal, I think you remember this. It was the most simplest of derivations. All I did was I opened up these. What happened when I opened up those? I got a straight line, correct? So it was something like A, B, ABC. It formed a straight line. The angle for a straight line is always 180 degrees. Therefore, I can say that these three angles always added up to be 180 degrees. Cool. Now, what was a median, guys? You remember what was a median? I want Arna to unmute.
Line.
Unmana, next question for you. I'll ask everyone, don't worry. Arna, what's a median?
The line that goes through the middle.
Okay, okay. Anything?
Or that divides, the triangle into a half.
Okay, okay, okay. Now, that is not necessary. When I'm talking about a median, guys, you remember when I drew a triangle, I said if I draw a line, I have A, B, C as a triangle, and this is M. If it's a median, what does the word derive from? Med, which means middle, correct? That means
Yes.
BM equal to MC. Can I say BM equal to MC? You guys
Yes,
agree?
sir.
This is when AM can be called the median. You guys agree with me? Now,
Yes,
the
sir.
most fundamental requirement of a median is that it should originate from a vertex. You remember A, B, and C are called the vertices, and singularly they are called the vertex A, B, and C. Now, there is a property that we're going to learn, or there's a concept where if we have a triangle, there is a line which is going to bisect the triangle. It need not necessarily pass through the vertex. If you see A is here, B is here, and C is here, in the first diagram, what happened? The line came through the vertex A. You guys can observe. But over here, there is a line that is cutting the triangle exactly in half. These two are exactly the same. When I'm saying same, area wise. Now, this line, is it passing through the point A? Yes or no?
No, sir.
No. So this is not a median. That's called a bisector. When I say bisector, what do I mean? What does bi mean?
Bi
Basic
means two and section.
Exactly. Yes, bisector. It's a line which is dividing the triangle into two equal halves, two equal parts. Is this clear? Is the difference between bisector and median clear?
Yes, sir. But how do we draw a bisector?
Yeah, so over here, look, BM can be equal to MC. It doesn't matter. But it does not pass through the vertex A. Now, these are more of a construction related concepts. Okay. But when I'm talking about median, it is very simple. If I have BC equal to 10 centimeters and he says AM is the median, BM will be 5 centimeters, MC will be 5 centimeters. I'm trying to see how much you guys remember of the previous classes. Now, Unmana, what's an obtuse angle, Unmana? If I draw something like this, ABC, what is angle ABC? Is it acute? Is it a right angle or is it obtuse?
It is an obtuse angle.
Why is it an obtuse? Your answer is absolutely right. Why is it an obtuse?
Because it is more than 90 degree and less than 180 degree.
Beautiful. So whenever I'm talking about any question, I want you guys to think about the reason behind it, the why behind it. There is nothing in math that does not have a why behind it, as simple as that. Now, you guys remember, let me erase everything on this slide so that I have some place. Oops, yeah. One second, guys. So what am I saying over here, guys? Sayed Nasir.
Yes, sir.
How are you?
Fine. Thank
I
you.
want you to talk today. Now, Sayed, can you give me the classification of triangles based on sides? What are the three types?
A, B, and C.
Not the vertices, the triangle types. Triangles are classified on the basis of sides and on the basis of angles. There are three each. Okay, let me give you a hint. One is equilateral triangle. What is the other?
Quadrilateral.
No, I want Syed to answer. Syed Nasir. Yeah, try. It's okay if you're wrong. This was something I discussed in the previous session.
Unequivalent triangle.
Pardon?
Unequivalent triangle.
Unequal triangle. Okay, good try. Priscilla, go ahead. Tell me.
So can you
Sir,
tell the question?
isosceles and scaline.
Priscilla, go ahead.
Sir, isosceles triangle and scalar triangle.
Yes. So, what's the
Can you
fundamental?
tell the question? Can you repeat the question?
I said we have plot of triangles, but fundamentally triangles are either classified on the basis of sides, that is the length of the sides, or they're classified on the basis of the angles that they form. On the basis of sides we have three, and on the basis of angles also we have three. What are the three types of triangles on the basis of sides? Side length. So we have equilateral triangle. What's equilateral triangle? All the three sides are equal. Correct? What is the next one? What is the other one, Priscilla? Okay, I think we've lost Priscilla. She's rejoining. Arna, go ahead.
Sir, isosceles.
Isosceles, beautiful. What's the fund of isosceles triangle?
Two sides of a triangle are equal.
Yes. And what's the last one?
Scaline.
Scaling. What's the concept of scaling?
Sir, all the sides are different.
Yes, unequal sides. Now, Arna, can you classify the triangles on the basis of angles and also give me the angles?
Yes, sir. Acute, obtuse, right.
Beautiful. What are these? Can you give me the angle measurements?
Yes, sir. Acute are the angles which are less than 90 degrees. Right
Yep.
angles are like 90 degrees, and obtuse are above 90 degrees and below 180.
Beautiful. Chalo. So I am sure that all of you have a good understanding of the previous concepts and you have it in your head. There might be certain details you might have missed out on, but overall, I think you guys have a good understanding and you haven't forgotten. Bhavya, what's up with you? You joined a little late.
Yes, sir.
All right. So anyway, we were just revising a few concepts that we discussed in the previous two sessions before I start off with today's. So there's nothing new that I discussed yet, but I wanted to start focusing from now. Cool.
Okay.
Now, let's look at the first slide. Now, this is called triangle inequality. It says, this is a theorem. What does the theorem say? It says that the sum of any two sides of a triangle is greater than the third side. That is a statement. That means I have a triangle and it says PQ plus QR is greater than PR. PR plus QR is greater than PQ. And PQ plus PR is greater than QR. Now, Is there a question or is there a doubt or is there a thought that has come to your head? Anyone? Is there anything that has come to your head when you've seen this theorem? Or you blindly accepted? Okay, the book says so, so I'm going to accept. What is it that came to your head when you saw this, guys? Speak. I'm talking to you. Do not type and waste your time. Talk to
So
me.
two sides, when you add them up, it should be greater than the third side.
Okay. Anyone else? What have you thought when you saw this theorem? Unmana, what struck you? Anything? What did you think when you saw this theorem?
So should I say the answer?
Yeah, Sayed, go ahead. What struck you?
PR plus PQ
Yes. PR plus PQ
is
is greater than QR,
then
correct?
PQ. Yes, sir. Yes.
Yes. So now I was expecting someone to ask me, sir, this is a theorem. Okay, very good. Sum of two sides is greater than third side. If I get a problem, I'll solve it. I'll get full marks in the exam. But no one asked me, sir, why?
Sir, I didn't ask why because I tried constructing that triangle and it didn't come as a closed figure.
Beautiful. But why did it come again?
What, sir?
Why did it come? You constructed it. Beautiful. You gave it a try, and maybe the theorem satisfied in a particular case, wasn't satisfied in the other case. But why should the sum of two sides be greater than a third side for it to form a triangle? Point number one, sir, it does not form a closed figure. Beautiful. But let's look at, there are actually three approaches that I want to take you through. But because of the time constraint, I will first go with two. If time permits, at the end of the class, I will explain the other one. Let's look at a very fundamental example, something that is very imaginary. First, we'll look at something based on observation. We will prove this based on observation, then we will prove it mathematically. क्योंकि एग्जाम में तो मैथमेटिकली दिखाना पड़ेगा. If you explain a story to a teacher, she probably won't understand. All right. Now, there is a field. Okay. There's a field. There is Priscilla standing over here. Okay. And who is over here? We have Unmana. Priscilla calls Unmana, saying, come here. Unmana, what are the ways that you can go to Priscilla? What are the possible ways?
From the side.
From the side, very good. So Unmana will move from here to here. Then she will take a turn, move from here, and she will reach Priscilla. Correct? Now, you can also go directly right through the field. You'll be like, this is the shortest distance. I will go right through the field. Do you agree? Priscilla, even you agree?
Yes, sir.
Now,
Yes,
when I did this, do you guys see a triangle that was formed automatically?
Yes, sir.
Yes, sir.
Now, if I name this A, B, and C, by pure observation, can I say that AB plus BC is greater than AC? Pure observation.
Yes, sir.
Very logical.
Yes, sir.
Yes, sir.
Yes,
If
sir.
she has to go along the boundary, pehle Unmana has to go from A to B, then she should again turn and go from B to C, which is obviously longer as compared to this direct shortcut that she can make through the field. Do you agree with me? Now, this is the fundamental proof of this. अब क्या करेंगे? We will look into the mathematical proof of this theorem. Let me erase the entire screen.